concept of transforming into an integral by taking a small amount of interval, which is 9 pi by L is equal to delta W, and we integrated it over minus infinity to plus infinity. So what we observed was that we can actually convert this whole series in the form of an integral. So instead of a summation, now it is replaced by an integral from 0 to infinity, and we have two coefficients, a as a function of w, cos wx, plus b as a function of w, and sine wx, and the whole integral is with respect to dw. So the integration parameter is w over here, it's not an x. Okay, and then we saw how this can be converted into Fourier cosine integral and Fourier sine integral. Okay, Fourier cosine integral and sine integral. So for Fourier cosine integral, we said it concerns with the even functions. So for even functions, we set b equal to 0, and Fourier sine integral concerns with the odd functions, and for that we set a to be equal to 0. All right, and yeah, so the value of this a and b, so that we obtained was, for this it is 1 over pi minus infinity to plus infinity, and we change the integration parameter from x to v. So it is f of v cos x v, wv, and it is over a period of the integration is over with respect to v. The integration parameter is v, it's not an x. So and same for the constant b, which is 1 over pi minus infinity to infinity f of v and sine wv dv. So I mean, that was Fourier integrals, and then when you write down the Fourier cosine integral and Fourier sine integral, so this will be like 2 times 0 to infinity, because we have defined this function to be an even function. So this is going to be equal to 2 times 0 to infinity for cosine integral, and for sine integral, this we said it is an odd function. So this is odd function into an odd function, so it is going to be an even function. So this is going to be 2 times 1 over pi 0 to infinity, the whole integral. That's what we saw in the last lecture, and we also did an example. And let me just see what example we did. I think it was e raised to x or something like that. E raised to kx. Yeah, so we had this example of f of x equal to e raised to kx for x greater than 0. X greater than 0 and k greater than 0. So for this, we derived the Fourier cosine integral and Fourier sine integrals, and we found this were to be equal to, this actually led to the equation for the Laplace sine integrals and cosine integrals. So we did the part for the cosine function, but the sine function, I asked you to do it by yourself. So I hope you might have done that. So we'll just do one more example, and we'll move ahead in Fourier transform, how to now use this concept of the Fourier integral to a Fourier transform. Okay. Let's take one more example. So f of x equal to x square for the range of 0 less than x less than 1, and otherwise x is going to be equal to 0. So x greater than 1. So x greater than 1, the function is 0. Between 0 to 1, it is x square. So we have to find out the Fourier cosine integral and Fourier sine integral for this. All right, so let's do it. So Fourier cosine integral, we have b equal to 0, so Fourier cosine integral, and we find out the Fourier's coefficient a to be equal to integral from 0 to infinity f of v. You see this description, so f of v cos wv dv. So f of v is nothing but your function, so that is your v square between 0 to 1. So between 0 to 1, so let me just remove this. So it's going to be 0 to 1, and you will have v square. Okay, and because otherwise it is going to be 0, so it is v square, and the parameter is cos wv. Okay, so this is going to be cos wv dv. So this is going to be equal to, okay, so now this is going to be integration by part, so it will require the integration by part. So we will have v square, and cos will be sine wv upon w, minus integral, we will have 2v into sine wv upon v w. Just know that we are integrating with respect to v, so this is going to sine wv upon v, so v integral from 0 to 1, and this is going to be equal to 2 over pi v square sine wv upon w minus 2v. Again, you will be doing the same thing, so I'm just writing it directly, minus 2v over w. So that's your first constant, and in the integration of this one is going to be minus cosine of wv upon w, and plus so 2v by w, and 2v by w will have integral of 2 by w. Again, you will have minus cos wv upon w, integration with respect to v, 0 to 1. So 0 to 1. So this is going to be equal to 2 over pi, and this remains as it is, v square sine wv over w minus, this is going to be plus 2v cos wv upon w square. This is going to be minus 2 over w square and sine wv upon w, 0 to 1. Okay, so this is, I think, not that difficult to evaluate. Let us just do it, and we'll just write down the answer, what will be the coefficient. Okay, so first term, this is going to be equal to, so we are putting v equal to 1, which is integration with respect to v, so limits are for v only. So we are going to be sine of w over w plus, this is going to be 2 cos w over w square minus 2 over w square sine w over w. Okay, and for the rest of the part, all terms are going to be 0, because sine 0 is going to be equal to 0 and sine 0. So that's your a coefficient. This is a. You can just simplify this. I'm not writing the whole term, and then you just simply plug it in your Fourier cosine integral f of x equal to integral 0 to infinity a of cos x w dw. So you just substitute the coefficients, and you will multiply it with wx. So this is going to be equal to sine Okay, so I'll just write down 2 over pi outside, 2 over pi to the integral sine. Okay, I think I don't need to write because it's just simply all these terms. I'm not writing this, all these terms. Okay, the term says all these terms multiplied by cos x w t w. This is going to be equal to fx. Okay, acha, this will be replaced by 1. So this is going to be 0 to 1. ठीक है, and then you can write down this whole integral equal to pi by 2 for the range of 0 less than x less than 1. ये जो पूरा इंटीग्रल होगा, ठीक है, this one whole integral, so that is equal to pi by 2 because this f of x equal to just f of x equal to 1. Sorry, it is x square. Okay, yes, it is going to be x square. So it is going to be x square into pi by 2 is equal to this whole integral 0 to 1 dw between 0 less than x less than 1. Okay, but yeah, I mean, we don't need to go for this step. If you are asked to just calculate the Fourier cosine integral, then this is what you just write down. This will be the answer. F of x equal to this. ठीक है. Okay. And yeah, so that was Fourier cosine integral. Now Fourier sine integral. So I would expect you to do it. Fourier sine integral. Fourier sine integral. So for that, we should have b to be determined. A set should be equal to 0 because that's good concern for the odd functions only. So yeah, just you do it on your own and just let me know what your answer, what you're getting. This is going to be 2 over pi integral 0 to 1 v square sine w dv. Okay, so if you have got the answer, you can just tell me what answer you're getting. So definitely this is going to be 2 over pi. This is going to be x f of x. Let's just write it down. F of x equal to 0 to 1. So have you any of you got the answer?
Yes, sir.
Okay, so okay, I mean let's just, I mean I would just expect some terms over here, and you will have your um, sine xw dw. Okay, I think that is what you might have received. Okay. Um, okay, so there are some examples which you should do it on your assignment. I'll just write down over here. You have to find out the uh, Fourier. Okay, let me just see. You have to find out the Fourier cosine integral. Okay, for this, whatever examples I'm giving, this, so f of x equal to is equal to 1 over 1 plus x squared, x greater than 0. इसके लिए होगा कोसाइन इंटीग्रल. ठीक है, for this one. Then second one, f of x equal to sine x between 0 less than x less than pi. Again, this is going to be the Fourier cosine integral, and otherwise it is going to be 0 for x greater than pi. Okay. Then we should have, now let's take a couple of examples for Fourier cosine integrals. F of x equal to cos x, and then you will have 0 less than x less than pi. Otherwise, this is going to be equal to 0 for x greater than pi. So now this is going to be Fourier cosine, Fourier sine integral. And let's take one more. F of x equal to e to the power minus x if it is 0 less than x less than 1, and otherwise equal to 0 for x greater than 1. So again, for this you will have the sine integral, Fourier sine integral. So 4 examples for 2 for Fourier cosine integral and 2 for Fourier sine integral. So that you should be doing in your assignment. ठीक है, let's move on. So now let us see that how one can transform from the Fourier integral to Fourier transform. ठीक है. So transform simply this is combining both your, you know, I mean the integral, it is in the form of sine and cosine. So we are just now going to introduce it the exponent. So combining both this sine and cosine in the form of an exponent, so that will actually give you the Fourier transform. So for this, we first look at the Fourier cosine transform and Fourier sine transform, and then we should look for the Fourier transform. It is also called complex Fourier transform. It is also called complex Fourier transform. Okay. So let's first look at the Fourier cosine transform. Fourier cosine transform. So Fourier cosine transform, it concerns again with the even functions. Okay, it concerns with the even functions. So for even functions, we know what is the Fourier cosine integral. So in this particular example, we simply just make the transition. We simply make the transition. Yeah. So in this a is equal to 2 over pi integral from 0 to infinity f of b cos wb dv. Okay. Okay. Now for Fourier cosine transform, what we do is that we would actually set your Fourier. We set this coefficient a as a function of w to be equal to under root 2 over pi into some function which I'm representing by small f hat as a function of w. So we set this coefficient to be equal to this in this particular equation, and when you substitute this value, we find that you have to, because this is 2 by pi, so if you write it into 2, like under root 2 by pi into under root 2 by pi, so 1 under root 2 by pi will get cancelled, and that will give you the format of f of f hat is equal to, so you will have 1 under root 2 by pi left with you on the on the right hand side, and the remaining integral remains as it is, this one. Okay, now in this integral, what we have, so we are integrating with respect to b, but because we want to express the Fourier cosine transform for the f of x, so we will actually shift our integration parameter from v to x. Okay, so in this integral, we shift our parameter from v to x, so that should give you f of x to cos v to x, so you will have cos wx dx. Okay, this is your Fourier cosine transform. Okay, this is your Fourier cosine transform. And if you take the inverse of this, so which means if I write down the expression, if I want to get back my function, original function f of x, then simply you will just say this is going to be equal to, it will be the same thing, just you will swap the functions f hat to cos wx. Yeah, and when you change it from this to this, what would happen is that your integration parameter will change from w from x to w. Okay, from x to w. Why it is that? Because ultimately you are writing this as a function of fx. So your integration parameter should not be in the x, it should be in w. And same for here, your transformation is in the form of w, so you are integrating it with respect to x. So this is called inverse Fourier cosine transform. Yeah, this is called inverse Fourier cosine transform. All right. Now, so that is for the Fourier cosine transform. And similarly, one can write down the expression for the Fourier sine. One can write down the expression for the Fourier sine transformation. Okay, so Fourier sine transform. So Fourier sine transform, what do we do? So we know the equation for b, this one. So we have this formula. So it will be simply 2 over pi 0 to infinity f of p sine wb dv. Okay. So in this format, what we do, we set b to be equal to the way we have done previously. So b is equal to under root 2 over pi, and again we will change the integration the way we have done here from b to x. So this is going to 0 to infinity. We'll have f of x into sine wx dx. Sorry. Uh, so this is going to be you are just writing it to be equal to fs hat. So you are setting this parameter into your original definition of b. ये वाला जो definition है, this is 2 by pi 0 to infinity. So you are setting b equal to this particular notation, and from this you can write down the Fourier sine transform, which is equal to 0 to infinity, and yeah, you will have the factor of 2 over pi 1 under root 2 by pi is equal to 0 to infinity f of x sine, and again you will change the parameter from b to x. So sine wx dx. All right. So this is your Fourier sine transform. Okay, this is a Fourier sine transform. It is actually simply nothing but if you see both the equations, you are simply just integrating the function with cos between 0 to infinity. Okay. And we are having this factor, that is because of the fact that when you are writing your coefficients, it is coming from there, 2 over pi. Okay. This we will see later on also when we are going to do the complex Fourier transform. I mean, when you are going to combine both the Fourier transform, sine and cosine, you will see the similar things. That over there you will have the factor of under root 1 over 2 pi. Okay. That we will see later on. Okay. Okay, that is a Fourier sine transform, and from this one can write down the Fourier inverse Fourier cosine transform also. So this is 2 over pi 0 to infinity f hat s, and you will have now this will change parameter from x to w. Okay, this is inverse Fourier sine transform. So we have seen these two things, Fourier cosine transform, this one, okay, and the Fourier sine transform. It's simply nothing but you are multiplying the function by the sine sinusoidal component, and then you integrate it from 0 to infinity multiplied by this coefficient. So we will combine these two now to find the complex Fourier transform. Okay. So at the moment we are just doing it mathematically. Okay, we are just doing it mathematically, and I'll just we'll watch one video also later on to see what actually it means, how these concepts are coming into mathematical picture, and how it is compared with what do we call that? In terms of the physical what is the physical interpretation of these transformations. Okay, that we'll see just in maybe after completing the complex Fourier transform. Okay, so let us, I think before we do the Fourier transform, let's do some examples. And we'll just do a couple of examples, and these are very simple examples. So we'll just take an example to get a feel what actually these transforms mean. So I have this function f of x equal to some constant k between 0 less than x less than a. Okay, and the function is equal to 0 where x greater than a. So if I just draw it graphically, then this is going to be equal to, so up to some part up to 0 to a, this is 0 to a, it is going to be equal to some constant k. So k is positive constant, x, and above x the whole function is going to be equal to 0. Okay, it goes all up to way to the infinity. So it has only the value between 0 to a, which is equal to k, and there is a point of discontinuity between these two. Okay, now for this, the actual question is that you have to find out the Fourier cosine transform and Fourier sine transform. Okay, so let's just see the Fourier cosine transform. So Fourier cosine transform, so we just apply the equation. So we apply the equation, this one. So under root 2 over pi 0 to infinity f of x cos wx dx. So under root 2 by pi integration from 0 to infinity, which is split into 0 to a and then a to infinity. So a to infinity, the function is 0. It's only between 0 to a, so which is equal to k, and it is equal to cos x, cos wx dx. So k cos wx dx. So it's a very simple integral. So just we just do it. The root 2 over pi into k, common out, cos is going to be equal to sine wx. Integration is with respect to x. So this is going to be w 0 to a. Okay, this is going to be equal to under root of 2 over pi into k into sine wa minus sine 0. So that is going to be 0. Okay, so this is going to be the Fourier cosine transform. All right. So that will be the answer for Fourier cosine transform. And for the Fourier sine transform, you will have f hat is equal to under root 2 over pi 0 to infinity, so 0 to a, and k into sine wx dx. So this is going to be equal to under root 2 over pi into k. This is going to be minus cos wx over w integral from 0 to a. This is going to be equal to 2 over pi k, and if we take the limits out, so this is going to be cos wa minus 1. Acha, if we okay, let's just take out this minus sign outside. Minus 1 into w. So that is a Fourier sine transform. Okay, so these are very simple examples, not much difficult to do. So let's do some. I will just do one more and then we'll move on to complex Fourier transform. So one more example, which I would expect you to do it. We'll just take a Fourier cosine transform. Okay, so f of x equal to e raised to minus x 0 less than x less than infinity. So over here it is given a full range. The exponential decay function is given to you and you need to find out the Fourier cosine transform. That is equal to under root 2 over pi 0 to infinity to f of x, which is equal to e raised to minus x, and cos, so this is cos wx dx. So we know the formula for this. We just did it in the last class. So you just apply that formula and just tell me the answer, what answer you are getting. So I think how many people are there? 1, 2, 3, 4, 5, 6, 7, 13, 23. So we are 23 only. I don't know what are the other people doing. Anyways. Okay, so answer, if you got the answer, just let me know the answer.
सर माइनस सर
हाँ बोलिए.
माइनस रूट ऑफ 2/पाई
Minus root, minus root of 2/5
into 1/w².
1/w². Okay,
w² plus 1, sorry, 1/w² plus 1.
w² plus 1. Okay, so everybody is getting this answer. I hope, yeah.
Not
Answer should.
not minus sign.
माइनस नहीं आ रहा आपका. अच्छा, just verify this thing whether you have a minus sign.
No minus sign, sir. Plus sign, plus sign.
Plus 1.
Okay,
Plus
plus
sign.
1. Okay, so yeah, that I think if majority everybody should be getting this answer something like this. Fourier cosine transform of fe to the power minus x. ठीक है, so that was the Fourier cosine transform examples, and now I will give you some examples. I don't know why this. अच्छा. Okay, so I will give you some more examples for the assignment. So these are very small examples. So I think we should not waste too much of time in doing right now in the class, but you better do it at your home with your assignment. So these are first. So these are the some more examples for which you need to find out the Fourier cosine transform. Okay, I'll just write down over here. So f of x equal to 1 between 0 to this one of 1, f of x equal to minus 1 between 1 less than x less than 2, and f of x equal to 0 for x greater than 1. So let me just write down here. You have to find out the Fourier cosine transform.
सर
F,
वहाँ पर x greater than 2 आएगा ना?
x greater than 2, 0. Yeah, this is going to be x greater than 2. Yeah. So between 0 to 1, it is 1. The between 1 and 2, it is minus 1, and above 2, the value of function is 0. So that is one example. Then let's take some more. So f of x equal to x square. F of x equal to x square, and the limit is between 0 less than x less than 1. Okay, and above 1, the value of the function is going to be 0. That is one example, and we'll take one more. Now this example, so you just see what happens with this. So sine, okay, f of x equal to sine x upon x. Okay, f of x equal to sine x upon x. The limits are from 0 less than x less than infinity. That you have to find out. So for this, you just find out what you can do. Similarly, you can do it for cos x upon x also, but I think, yeah, just do it first for this one and then see what answer you get. And if you don't get any answer, then just see what should be the reason. Can we not get, why can we not get, or can we get to the transform for this? So these three examples we should be doing. Okay, and we will do the example. Now we will go for the complex Fourier transform. What's the time now? Okay, 9:20. I think let's do it maybe tomorrow. So tomorrow we should complete this whole point of Fourier transform. So we'll do it tomorrow. So we'll see this complex Fourier transform, where we are going to combine both the cosine and sine transform, and we shall derive a general notation for the Fourier transform. And we will watch also one video which would indicate what exactly this Fourier transform means. So ultimately, the purpose of using this Fourier transform is to decompose the frequency. No, the purpose of using this, decompose the signal, and that is the purpose of using this complex Fourier transform or Fourier transform. So that means that if you are having some wave given to you, which is multiple, which is a superposition of multiple waves, and if you want to identify that what are the waves which are actually involved in this whole pattern, I mean the way what I have drawn over here, so this should be complex, this should be transformed with the help of this Fourier's idea, and it should give you the series of harmonically sinusoids with a different frequency. So for example, some waves having this larger frequency, some waves having lower frequency. So my drawing is not very better, but what I'm trying to say is that if you have a signal given to you, and if you want to identify what are the frequency components in the given signal, then one can apply the Fourier transform, and by applying the Fourier transform, we are actually separating this whole signal into its constituent frequency components. Because if we see these waves, it has a combination of multiple waves. It is having a different frequencies which are superimposed on each other, and we want to identify that which are these frequencies, f1, f2, f3, f4, all the waves. So they can be decomposed with the help of the Fourier transform. Okay, so that we shall see tomorrow by observing one video. Okay, so thank you for your attention, and have a good day. Yeah, just finish this examples, and as I said, yeah, write down all those examples that I am giving you in the assignment in a proper notebook, and you will be uploading all the examples, whatever you are doing, in an assignment book, and that will constitute 10 marks. तो आपका 20 marks रहता है internal का. I think I told you on some couple of lectures ago. So 20 marks है internals के, उसमें से 10 marks assignment के रहेंगे, and 10 marks you will have a class test. ठीक है? Okay. So thank you very much. Have a good day. Bye.
Thank you, sir.